Hello, I'm Professor Richard Tamboro, Daytona State College. Today I'm going to demonstrate how to test a hypothesis about a claim. The problem we're looking at is a hypothesis test where the standard deviation sigma is unknown. The population standard deviation is unknown. When that is unknown, we use a t-distribution formula. That formula has a component of degrees of freedom, which is the number of samples minus 1. That's the hypothesis test. Let's look at our problem. There was a survey, a randomly conducted survey of U.S. households, and in those households is testing a claim that the number of cats per household is 2.0 cats per household. Okay, the survey results, randomly collected data, is listed here. On top, we have the hypotheses. The H sub 0, which is the null hypothesis, is that there is 2.0 cats per household. The null hypothesis is unbiased, and it always has an equal sign. The test the claim statement tells us about the alternative hypothesis in this case, and less than, and we use the less than symbol. We stick with 2.0 for mu. The data from the 28 households surveyed revealed 1.8 cats per household with a sample standard deviation of 1.1. Because we have a sample standard deviation, again, we subtract 1 from n and find the degrees of freedom. The significance level is 0.10. That's given in the problem. And the critical value we look up on our table. So we need to know the degrees of freedom and the significance level of 0.10. We find a critical value of negative 1.34. The critical value has to be negative because we're doing a less than hypothesis test. What I'll do next is draw a picture of our hypothesis test and the critical value, then we'll work the problem. So I'll take the data and make the graph. So the graph is basically a bell curve. Population mean is in the middle, and 2.0. We typically label the line. This is a t-distribution. That's a t-line. It's similar to a z-line. 0 is in the middle, and then we set up the rejection region. The alpha goes in the left tail in this case, and our critical value is negative 1.34. Next, we'll calculate the test statistic. If the test statistic falls in this rejection region, then we will reject the null hypothesis. If the test statistic falls between 0 and negative 1.34, we will fail to reject the null hypothesis. Okay, let's conduct the hypothesis test using the test statistic. So we start by substituting into the formula. X bar is 1.8, mu is 2.0. Okay, so the first thing the formula does is compare the sample mean to the population mean. Then we will divide by the standard deviation, and that is divided by the number of samples. Okay. When we apply that formula, probably by using a calculator, we get a result of negative 0.962. Negative 0.962 standard deviations to the left of the mean. I'll add that to my list. And now I'm ready for a conclusion. Okay, so the critical value is negative 1.314 standard deviations to the left. The test statistic is 0.962 standard deviations to the left. Let's see, I'll just label that TS for test statistic. Okay, the test statistic is not in the rejection region, so the conclusion would be fail to reject the null hypothesis. So I'll add that to my list. Okay, so fail to reject the null hypothesis. The possibility of an error type exists. We do not calculate the error type usually in elementary statistics, but we identify the possible error type in this case is 2. Anytime you fail to reject the null hypothesis, you have a possible error type 2. Okay, so our conclusion is fail to reject the null hypothesis. So we don't reject the null hypothesis, so the data is supporting the null hypothesis. So there is not sufficient evidence to support the claim of less than 2.0 cats per household. Okay, so the null hypothesis was not rejected, so the data, the survey supports the number of cats per household is not less than 2.0. It's indicating that it is 2.0. Thank you very much. This is a traditional hypothesis test method.